Hello again. Today we're going to look at a few things: interval notation, domains and ranges of functions from the graph, and piecewise functions. But we'll begin with interval notation. What is that? That is a way of describing sets of numbers. For example, supposing I want to describe a set of numbers greater than 2. In set notation, that would be, we put a brace here, we put the set of x's such that x is greater than 2. So that's the set notation way of describing numbers, all the numbers greater than 2. And graphically what we're looking at is all the numbers greater than 2. We could use a circle to represent that we are not including 2, or we can use a parentheses, an open parentheses, opens to the right, which means you're starting at 2 but you're not including 2 and you're going to the right. Well, interval notation looks similar to what we did on the number line here, where we start with a parentheses opening to the right, and we put 2, so we want all the numbers from 2, not including 2, all the way up. Since we're going on infinitely, this goes up to infinity, and we always put a parentheses around infinity or negative infinity. Let's look at another example. Okay, suppose we wanted the set of numbers less than or equal to -1, and graphically on the number line that looks like we want all the numbers to the left of -1, including -1. So here we put a solid dot at -1 and then shade to the left. Or if we use another type of notation which will be similar to what interval is, we put a bracket but it opens to the left. This is a square bracket, opens to the left, and we shade to the left. So in set notation what we're talking about is a set of x's such that x is less than or equal to -1. We want all the numbers that are less than or equal to -1. In interval notation, it's going to be similar to this number line here, where we start at negative infinity. Remember, parentheses always around infinity. We put negative infinity, and we're coming up from negative infinity all the way to -1, and we're including -1, so we use a bracket. So that's the gist of interval notation. So when you have an open interval, you use a parentheses. When it's closed, in other words, you're including that endpoint, you use a bracket. And around infinity, you always use parentheses. So you should study the following page to get used to using interval notation. We're going to look at two things today which are very important, especially if you're going on in math, and those are the domain and ranges of relations or functions. And we've discussed that a little bit, the difference between a relation and function, so we won't get into that too much here. But what is a domain? The domain is a set of all first components of an ordered pair. So you think of when you make an xy point, the set of first components, if you have a line and they're all points for that line, the first component, all those numbers comprise the domain. Or you could think of it as the set of all x values. We have ordered pairs in the order of x and then y. It's the set of all x values. And when you get into functions, we're really talking about all the set of inputs, what I can put into that function, into that equation. The range now is a set of all second components of an ordered pair, which are the y values. Those are the y values if you're thinking of x and y coordinate pairs. So the set of all second components of that ordered pair. Or in terms of a function, it's the set of all the outputs of that function. So we can find the domain and range of a relation or a function just by looking at the graph. If the graph is done well, we can actually look at the domain and range. So let's do that. All right, here we have two graphs, and we're going to find the domain and ranges of these two graphs just by looking at the graph. And what we're going to do furthermore is we're going to list those numbers, because remember they're sets of numbers. We're going to list those numbers in interval notation. So let's look at graph 1. We see we have this function here. It goes up and it goes down, and it starts here and it ends here. It's not going any further because there would be arrows on the graph if it were. So we're kind of starting here and ending here. So what is the domain? What it looks like is coming from -4 out here to 3 here. It's not listed 3 on the axis, but we could assume here's 2, here's 4, must be a 3 here right in between. And so my domain is from -4 to 3, and including those, because there's solid dots right at the endpoints. So how would I write that in interval notation? We'd go, my domain goes from bracket -4, comma 3, and close bracket. So that's the domain of this function up here. Now let's look at the range. Well, the range are the set of y values or the second coordinates. And the range of values here look like they're coming, starting down here, going up here. That's all the different y values here. So it looks like it's starting here and going up here. And so, remember, this is the y-axis and this is the x-axis. So, it looks like -1 from the bottom here, -1. It's not written again, but we could assume these are each 1 if we look at the scale. -1, and it stops here at 3. So our range looks like it's from -1 to 3. Close brackets. And we use brackets because we're including those endpoints. Now let's look at another relation. This is not a function, by the way, because it doesn't pass the vertical line test. But it is a relation. It's actually an ellipse. Close to a circle, but not quite a circle. An ellipse. It's elliptical. And we want the domain. The domain looks like it's from what? All the x values, all the first coordinates, would be from -3 to 3. And it includes those endpoints, so we go from -3 to 3. And the range looks like what? Well, all the points from, all the y values from -2 to 2. So the range would be -2 to 2. Let's take a few more examples. All right, here we have two more graphs. The first graph up here is the graph of actually an absolute value function, and it looks like a V. So we want to know the domain. And notice on the graph we have two arrows here, which means it goes out this way. It goes out infinitely. So we want to know the domain. But think the domain is a set of inputs or x values. And as you go up this way infinitely, you're going to get all the x values there are. So the domain is actually infinite. And how do we write that? It's all real numbers. How do we write that? In interval notation, we go from parentheses, -∞, comma, infinity. And so that means all real numbers. -∞ to infinity. The range now is the set of corresponding y values or the second coordinate or the outputs. Well, the range here, we know there's nothing below the x-axis here. It looks like it hits the origin and then goes back up. So the range is actually everything from 0 upwards. So the range is going to be bracket 0 to infinity. So that's the range of that graph. Let's look at the second graph here. Here we have a graph of a straight line. And interestingly enough, when you have a straight line with two arrows, the domain, just like the one above, is going to be all real numbers. -∞ to infinity. But with a straight line, the range will also be all real numbers. You think as we move up this way and down this way, we're going to hit all the y values there are. So the range is also all real numbers, -∞ to infinity. And that's true of any line except for the horizontal line and the vertical line. Any line, the domain and range is going to be all real numbers.